This video is entitled SQL Dates, a Date to Remember. Now I'm not talking about these kind of dates, nor am I talking about these kind of dates. I am, however, talking about dates on a calendar. Using dates in SQL is crucial because we do date manipulations to answer questions all the time. So hopefully this will be useful as we show you lots of different capabilities in SQL. Here are the topics we are going to cover. First, I will cover date data types. Next, I will cover date functions and the way that they can be used in a query. I'll next cover formatting dates so that we can see them exactly the way we want or exactly the way that our client wants. Finally, I will cover converting integers or strings into a proper date data type. Here are the date data types. I know this is small, but they include time, date, small date time, DateTime, DateTime2, and DateTime offset. Let's look at those in the Microsoft page so we can get a better view. Now we see time is just hours, minutes, seconds, and the accuracy here is 100 nanoseconds, and it's between 3 to 5 bytes. Date is just the date, not the time. Its accuracy is at 1 day, and it's 3 bytes. Small date time has a date and a time. It only goes from 1900, January 1st, through 2079. It's accurate to a minute, and it is 4 bytes. The next is date time. It goes from 1753 through 9999, and its accuracy is a fraction of a second, and it takes 8 bytes. Now, we get to DateTime 2, and it goes from 1101 through 1231 of 9999. Its accuracy there is at 100 nanoseconds, and it takes between 6 and 8 bytes. And finally, DateTime offset. DateTime offset defines a date that is combined with a time of day based on a 24-hour clock, like the DateTime2 data type, but it also adds time zone awareness based on UTC, the Universal Time Coordinate, or Greenwich Mean Time. Where I live, it is an offset of 7, meaning I am 7 hours behind what the time is in Greenwich, England. The next topic I'm going to cover is date functions. Here's an example of a date function. I'm going to do several more in SQL Server, but let's just get started here. Notice that I have a select, and then GETDATE, left parenthesis, right parenthesis, is the function. Then I say as, and then I give this alias a name, and that's the name of the column as it's displayed. So GETDATE is going to grab the date from either your computer or the server and display it at that exact moment in time. So this is that query in SQL Server. I highlight it, run it. Notice that here is my column title, and here's the date and time that I ran this query to get the system date and time. Let's go to the next set of functions. First, I am going to show the date that comes from a table called master statement. Statement date is the date time column. Master statement is a table that holds SEC accounting data. I highlight that, and down here in the answers, I see a year, a month, a day. All the times are set to 0 because they didn't come in with a timestamp. So that's great. Now let's do a query from that table and that column. What I'm going to do is extract the year from the statement date. So let's highlight this, run it, and it shows only the year. Now we see it over and over again because every row has a date in it, and so we see a year for every row. If we want to see each year only once, we will add the distinct operator here. Notice also that I put my as column on the next line because I don't want it to run off the screen. Also, when I do a lot of SQL programming, I'll often go vertical at certain points so that I can fit it all onto a screen. Let's run this. And notice that we see two year numbers, the year 2020, the year 2021. So it extracted the year from every statement date, but only listed the unique years. It stands to reason that if we have a year function, that we will have a month function. And it's set up exactly the same way, only this time it's going to extract the number of the month for each statement date. So let's highlight this, run it, and we'll see down here at the bottom that there's a number for the month, and I think that they're mostly 3, 6, 9, and 12 because they were quarterly statements. Now again, you'll see that those are all repeated over and over. So let's make the same modification that we did to the year, and we will do distinct month. So we should see each month number only once. And again, it's grabbing it from the statement date, and I put the new column name on the next line in a vertical way so that it wouldn't spill off here to the screen to the right. So let's run that. And again, we see 3, 6, 9, and 12. Those are all the unique month numbers that we have in our data set. It stands to reason then, if we have a year function and a month function, that we should have a day function. Again, we're applying this day function to the column statement date, and it has to be a valid date in order to work. Our new column is called day number. So let's run it, and we'll get one day for every row in our data set, but we will notice that they are concentrated between the numbers 30 and 31. That's because statement dates from the SEC all occur at the end of a month, and in fact at the end of a quarter. So let's do what we've done before, so we see each value only once, and we'll do that with a distinct. Let's highlight this, run it. Now we see the numbers 30 and 31, and those are the only two values that are unique that come out of day of statement date. Calculating the difference between two dates is a very common task. In the past, it's been difficult sometimes, but with the DATEDIFF function, it's relatively easy. So here is our DATEDIFF function. The first argument is the granularity of the difference, meaning are we looking for a difference in years, months, days, quarters, or weeks. In this instance, I'm going to look for the difference in days between the statement date and year-end 2021. The column is called Days Until End 2021. The table again is master statement, and I am going to order it such that the most days to the end of the year are listed first, to the least days, and they're listed last. So in effect, it's going to list the date difference from the earliest days first. let's highlight this. We will execute it. Notice here in our answer that we have numbers from 549 days till the end of 2021, and here at the bottom it's all the way down to 275 days. So a DATEDIFF function can be very powerful. People use it all the time to make calculations of date difference. They do it to calculate interest or payments or a wide variety of things in business. If you have a DATEDIFF function, it stands to reason that we would have a DATEADD function. So here's the DATEADD function. The unit that we're looking at, or the granularity, is days. This first argument is how many days we are going to add. In our case, we're adding 180 days. We will add that to the statement date here in our table of master statement. Then here's our alias. Our column name is 180 days after the statement date. Let's run it, execute, and we have lots of different values here that are 180 days after the statement date. Now, a lot of those dates are duplicated, so let's eliminate the duplicates, and I'll wait just a second to see. Ask yourself, what would I do to eliminate the duplicates? Okay, I'll hit delete, and we will look here, and if you guessed distinct, you would be right. So it's the same exact query as before, and I only want to see the unique or distinct dates 180 days after the statement date. I will run that, and that tells me that I only have 4 unique statement dates. So here are the 4 days 180 days after. Let's go ahead and look at the date name function. I put several in a row here so we can compare what they do. The date name function takes 2 arguments. Here you're seeing the granularity, or the part of the date or time. The second is the date column. In this case, it's not a column, but the getDate function, because it lets me show how to use it. If this were a column name, I would have a from clause under it. So this first one is year, and it's going to return an integer value of the year. Quarter will return 1, 2, 3, or 4. But this third one, month name, will return a string. So it will say something like February, March, April, or in this case, July. Let's go ahead and run this, and let's look at the results. Noting that this is the 21st year, it's the 3rd quarter, it's the month of July, it's the 193rd day of the year, the 12th day of the month. The standard week says it's the 29th week. We'll look at something else in a moment. We note that it's Monday. It's the 15th hour, the 4th minute, the 6th second. We see the fraction of millisecond, microsecond, nanosecond. This is the ISO week. What that means is the first week of the year that has a Thursday on it is listed as week 1, and then we have all the weeks following that. So in this year, that's 1 week different than our standard week number. So that's the way that we would look and use the date name function. I think everybody should have that in their tool belt, because we see that all the time, especially in business usage. Now I'm going to cover DATEPART. DATEPART has a lot of similarities to date name that we just did. A major difference, though, is that it always returns an integer. So The structure and the format's the same. I have a select date part, the part of day or time that you want to list, and then the date column, or in this case, the date function. I'm going to execute. Let's go look at the answer. And see that for the integers, they're all the same, 2021, third quarter. But in this case, the month is 7, and the weekday is 2. It's the second day of the week. So it's similar. It returns the same information, but none of these have string values. So that's a little bit about DATEPART, which is a close cousin to DATENAME. Let's take a look at 3 common DateTime functions. The first here is current timestamp. Notice that there is no parenthesis after the function right here at timestamp. I execute this and it gets the current date and time from the server, not from the client. So if I'm not sitting at the local installation, it's grabbing the date and time from the server. Let's look at GETDATE, and GETDATE and current timestamp do the exact same thing. So let's highlight this, run it. You'll see that we get the exact same answer, slightly updated, and it also returns the date and time on the machine that SQL Server is running on. Let's delete that. And this time let's do the UTC date. So this is the date and time in Greenwich, England. And from where I'm sitting, it is a 6-hour difference. So I execute, and I can see the 6-hour difference here because where I'm at, it's 12:01 p.m. and in Greenwich, England, it's 6:01 p.m. So a lot of times companies with many locations gather the UTC date and time in order to have the same date time across different time zones. The next thing to cover is date formats. You can set a specific format at the start of your session depending on the format of your data. Let's imagine for a moment that your data is coming in a day, month, year format. So I can set the format to be day, month, year, choose go. That means that it takes effect. Here I declare a variable called @DateBar of data type DateTime2, and I set it equal to, in parentheses, the 8th day of the 6th month, 2021, 7:55 a.m. with a decimal. When I do the select @ variable, then I will see this, but it won't say August 6th, it will say June 8th. Let's see the date format in SQL Server. To reiterate, date format sets the order of the month, day, and year date parts for interpreting date character strings. These strings are of type date, small date time, DateTime, DateTime2, or DateTime offset. So here's the example that I gave before. I'm setting my date format to be day, month, year. What I want to see is June 8th of 2021. So let's run this. And in fact, it says 6/8/2021, and that is June 8th. Now let's do a different version to see how it works. Again, I'm going to choose day, month, year, but this time I'm going to format my date to be in a month, day, year. Now when I run it, notice that it gave me August 6th instead of June 8th. So the point here is that you have to be consistent. whatever your date format is set to right here has to be consistent with how your data is coming in. Now, I use literals, but in the real world, most of the time, people get many lines of data and they have to convert it to an actual date time, and it needs to be consistent with what your date format is set up as. The last topic I want to address is converting integers to dates. Now, you might have occasion to have a table with 3 different columns that are all integers. The first column could be a year number, the second column could be a month number, and the third column could be a day number. So we could use this DATEFROMPARTS function to convert those integers into a formal date or DateTime date. So here's my example. I'm not taking this from a table yet, but I'm converting this 1992, 6, and 8 into a date using this DATEFROMPARTS. When I run it, you'll see that I indeed have a date. The second example would be changing the integer columns into a date in the table. So I will show this in a moment in SQL Server, but I update my dates table and I set the date column, which is null at this point, to be DATEFROMPARTS and grabbing 3 different columns, and then it updates it. So let's go look at these in SQL Server. Here is the example in SQL Server. Notice I have 1992, it's an integer. I have 6, that's an integer for month, and I have 8, which is a day, and it's also an integer. So let's highlight this, execute, and DATEFROMPARTS took these integers and returned a valid date. Now, we're going to look at dates, but let's look at the table. I think it's going to be tiny here, but we have column 1 is year, the second column is month 1, the third column is day 1, and the fourth column is a date column. So what I want to do is update the dates table, and I'm going to take elements of the first 3 columns and transform those into dates for the fourth column. So let's highlight this, run it. Now let's go back here and look at the dates table. And now we have 4 valid dates that were built from the first 3 columns. For this operation, I want to illustrate how to take a column that has DateTime data, but that is of a character data type, and how to convert it physically into a DateTime data type. So the column that we're looking at here is DDate. You'll see that it says nvarchar 50, and this is the DDate column right here, and you can see that it does indeed have date and time in it. Now it has a lot of precision there, so I'm going to call it DDate1, and that'll be like a temporary column, and I'm going to make this a date time 2 data type because of the precision, and then I'm going to save it. After I save it, I'm going to run this query. Now what I'm doing is I'm taking the DDate column, I'm applying the convert operator, and I'm going to take that converted data and stuff it into the DDate1 column. That's my temp column. Let's run it, and we have a lot of rows that are affected, 42,960. So we can come back to our table here. I'm going to move DDate up to the top, Here's the DDate one. I'm going to get rid of the original. That's the one that has character data in it. I don't need it anymore. And then I'm going to rename this new DateTime just to DDate. Then I'm going to save. I can go look at my data again from this table. It looks probably pretty much the same, except that column now has been changed to a DateTime data type, and we can apply all the DateTime functions to it.